everyone, we are Team 4 from ITA of Gokaraju Rangaraju Institute of Engineering and Technology. Our guide is Dr. YJ Nagendra Kumar, our head of the department. I am here to present our mini project on IntelliProf, a Langchain powered research assistantship streamlining inquiry. Here's the abstract of our project. Professors struggle with time consuming tasks like manually processing and summarizing research articles. IntelliProf addresses these challenges by automating tasks and leveraging LangChain's capabilities. It extracts and summarizes key information from articles, saving professors valuable time. LangChain's technology, including loaders, text splitters, and vector databases, allow IntelliProf to understand natural language queries and deliver relevant information efficiently. The existing system has many issues. Professors often spend significant time manually reading and summarizing research articles. Existing tools like ChatGPT have character limitations which hinder comprehensive summaries. Additionally, traditional search methods make it challenging to find relevant information within research articles, leading to inefficient information retrieval. To resolve these issues, we propose a system where we can load the document, split the data in them into chunks, and then create numerical representations of these chunks. This makes large amounts of data to be handled easily. This provides efficient retrieval and accurate answer generation. We can first load the external document, split the data into chunks, create embeddings for these chunks, and store them into vector database. The query is then put into the model and the relevant chunks are retrieved from it and the answer is generated. System specifications include an LLM model, a transformers model to create embeddings. Coming to the use case diagram, as you can see, the user first loads the data and the server splits the data into chunks, creates embeddings, stores the embeddings into a vector database, and retrieves the relevant chunks. The user then provides the question and answer prompt and the answer is retrieved. Same goes with the class diagram as well as the activity diagram. Coming to the sequence diagram, the professor is the user here and he provides the URL into the system. The URL is loaded into the server and the model processes the URL, generates embeddings and stores it into the vector database. A query is prompted by the professor, the query is processed by the server and relevant chunks are retrieved. Then the answer is received by the professor. The deployment diagram involves loading the LLM model and research paper URL into the system. System architecture involves data loading, splitting the data into chunks, importing the LLM model, generating embeddings, vector store initialization where we embed text and store embeddings, load existing embeddings from a file, fetch top and relevant chunks. Then the question and answer is given. In our model, we query from a research paper where the researchers identified the drug to treat COVID-19. We first load the URL of the research paper and follow the necessary procedures. Then we query the model by giving a question, identify the repurposed drug for COVID-19. The model accurately retrieves the answer from the URL of the research paper. First, you need to install several packages necessary for the code to run. Accelerate transformers torch are used for the transformers model. After installing the packages, you need to import the necessary libraries. First step involves data gathering. The system starts by fetching research articles using loaders like text loader. For unstructured data like URLs, it employs unstructured URL loader to handle web addresses directly. You load documents from a specified URL using the unstructured URL loader. The second step is text processing by splitting the text. Once loaded, the articles are divided into smaller, manageable chunks using a text splitter like character text splitter. The system utilizes recursive text splitter, which can handle various separators to ensure proper segmentation based on article structure. Next step is inserting the model. You can use Dolly V23B by Databricks to generate text. Transformers pipeline is used to generate text based on the input prompt. You need to convert sentences into embeddings in the next step. Sentence transformer is the library we use to generate sentence embeddings. All MPNet based V2 is a pre-trained model to convert sentences into dense vector representations. As you can see, these are the embeddings generated. The next step is storing these embeddings into a vector database. First, you import the necessary libraries. We create a vector store class to store the embeddings into the vector database. Here, this function is used to get the embeddings path and to dump embeddings and to retrieve the relevant chunks. Then we create an instance of the vector store class and prompt the model by giving the question. Then we retrieve the answer by using the model.